Hey guys, so
Okay,
today we'll balance chemical equations. And we'll use Khan Academy as an example.
okay. So, for this chemical equation, typically what you want to do is you start with one of the most complex molecule or compound. So in this case, this one is pretty complex because it has very high subscript numbers. So if you assume that we have one of this molecule, then and then we have to look at what kinds of atoms are inside this molecule. So because of the subscript 3, we know that there should be 3 iron atoms on this side. And we know that both the reactant side and the product side of the equation has to be the same. So if there's 3 on this side, we need to balance accordingly and put 3 on this side. And then going back to this iron oxide, we also have 4 oxygen molecules, and that also needs to be balanced. So, and since there's 1 oxygen in each water molecule, we know that there needs to be 4 water molecules to balance the oxygen. And now let's look at everything that we have so far. So we have 3. Oh my god, this is hard to write with. We had 3 iron. We have 4 times 2 is 8, so that's 8 hydrogen. And then we also have 4 oxygen. And then on this side, we have 3 iron, 4 4 oxygen, and then in order to get that 8 hydrogens, since we have 2 in each molecule, we would need 4. And so let's put that into Khan Academy. Like 3, 4, 1, 4.
Alright, let's just piggyback off of what Ian said about earlier. So we're gonna find the more complex. So I'm just gonna start with um sodium, this one, the one I'm underlying. So let me just write that out. And I'm just gonna draw a line right here to show that that's the other side of the equation. So this one's pretty easy actually. This is very easy. You could immediately tell this is 2112. Okay, but how did I do it that quickly? You may ask. Well, it's because. All right, so sorry. Wait, I'm just trying to write all this down. Okay, so yes, this sodium right here, and you notice that there's one of each. So, and you notice there's two of each. So logically speaking, if there's one bromine right here, right, and there's two bromines right here, you got to make this a two, right? And since there's two, this is a diatomic chlorine. There's two diatomic chlorines. Then clearly you gotta put two right here to match this up. And since I only used one of the two chlorines here, and since I also use one of the two bromines here, the one is 2121. Sorry, not 2112. It's 2121. So let's just put that down. Um, and we know this because there's um one diatomic chlorine, so there's gonna be two chlorine molecules because the subscript is two, and because that there needs to be two chlorine. And since there's two chlorine, and since NaCl is basically has two chlorine and two sodium atoms, you're gonna have to need two sodium atoms on the other side. And since the sodium's correlated with this bromine, you need two bromines to match it up. So that's why you put a one here. And you put a one because there's already two bromine atoms because of the two subscripts, which we talked about at the previous video. And yeah, let's just check this. All right, we got this right. So yeah, that's about it.